Okay, hi everybody. Let's go over example one, where we're going to integrate the following. So here we have the integral of 5 dx. So this aligns with this property 4, where it's just a number, a coefficient, and when we take a derivative, or I'm sorry, when we take an integral of this, it's going to be kx plus c. So for example 1a, the integral of 5 is just going to be 5x plus c, and that's the answer. So now let's go ahead and jump to number or letter B. And so it just says the integral of dx, but what we have here is just this invisible 1 right here. And so much like letter A, when we take the integral of 1 dx, this would just be 1x plus c, or x plus c. Okay, let's jump to letter C. And we have the integral of x to the fourth dx. And this example aligns with example or property 5 here, where we're going to add 1 to the power and then divide by that value that we get. So the integral of x to the fourth is going to become x to the 4 plus 1 over 4 plus 1 plus c. And so if we simplify this, it becomes x to the fifth over 5 plus c. And you could write x to the fifth over 5. I like to write my fractions in front, but it's your own preference. They mean the same thing anyways. Okay, let's jump to letter D now. So we have x to the 3/4. So this one is very much like letter C with the adding 1 to the exponent and dividing. But here we have a fraction, so it's going to be a little less clean, but it's the same process nonetheless. So we're going to have x to the 3/4. Let me rewrite that. Plus 1 all over 3/4 plus 1 plus c. Okay, so some fraction work. 3/4 plus 1. I could change that 1 to 4 over 4. And so I'm left with 7/4. So coming back to the problem, what I end up with is x to the 7/4 over 7/4 plus c. And just to rewrite this, it becomes 4/7 x to the 7/4 plus c, where this fraction just flips up, reciprocates. So that's letter D. Let's go ahead and look at letter E now. We have 1 over x cubed dx. So this is a different type of example, but it definitely relates to the previous examples where we gotta add 1 to the power. So much like with derivatives, we would bring up this x cubed to the top numerator. So let me rewrite this. So this becomes the integral of x to the -3 dx. So now I can take the integral of this by using the same process as adding 1 to the exponent and dividing it by that value. So what this becomes is x to the -3 plus 1 over -3 plus 1. And if we simplify this, oops, forgot my c. It's easy to forget the c. But if we simplify this, we get x to the -2 over -2 plus c. And then what I typically like to do again is just make it a fraction. So -1/2 x to the -2 plus c. And so, let me try this again. I guess I want to make this exponent positive. So I'm going to bring it back down to the bottom. And so what I end up with is 1 over -2x squared plus c. And that could be a final answer. Okay, moving on to letter F, we have 4x cubed. And this example is a little different because we have a coefficient attached to the x cubed. It's not just the x cubed by itself. But much like with derivatives, the coefficient just comes along with your derivative, comes along the ride. It's the same idea here. The coefficient is just going to come along with this integration. So we're still going to add 1 to the exponent, divided by that value, and the 4 is just going to come along with this. So what we have here is just going to leave the 4 alone. 4 times x cubed plus 1 over 3 plus 1. And this becomes 4x to the 4th over 4. And I can cancel out these 4's. Forgot my c's. See, it's easy to forget. And what I'm left with is x to the 4th plus c. This is kind of like that example in the beginning of the section. Okay, moving on. We're going to come back to the top and work on letter G. So this example, there's more than one part to it. It's not just one integration to worry about. We have a polynomial here, but we can just treat each part separately due to this property here, 2 and 3. We can just integrate them separately. So here, I have 5x cubed plus 7x minus 3. I can just integrate each one of them on their own. So what this becomes for this first part, 5x cubed is 5 times x3 plus 1 over 3 plus 1. And we can do the same thing with 7x. So 7 times x to the 1 plus 1. Think about there being an invisible 1 right there, divided by 1 plus 1. And then here we just have minus 3. Recall when we just have a coefficient or a constant, we just tack on an x there. So this 3, when we integrate that, just becomes 3x. And don't forget your plus c. Okay, let's go ahead and simplify this out. We have 5x to the 4th over 4 plus 7x squared over 2 minus 3x plus c. Okay, and that is the final answer. All right, moving on to letter H now. It is x to the 1/3 minus 5x. So once again, a couple moving parts, but we can integrate them on their own. So we have a fraction here, so it's going to get a little, it's not going to be as clean, but same process as always. And what we have for the solution would be same thing, add 1 to the 1/3. 1/3 plus 1 over 1/3 plus 1. Minus 5x to the 1 plus 1 over 1 plus 1. And so if we simplify this, doing your fractions, 1/3 plus 1, that's just 1/3 plus 3 over 3. So that's 4/3. So this becomes x to the 4/3 over 4/3 minus 5x squared over 2. And don't forget your plus c. Okay, so if we could clean this up, the 4/3 reciprocates up, it flips. So this becomes, hopefully I don't run out of room here. This becomes 3/4 x to the 4/3 minus 5 over 2x squared plus c. Hopefully that's legible. Okay, moving on to letter I now. Getting a little scrunched up here, but we have 1 over x minus 6 e to the x. So this 1 over x, that aligns with the property above here. So the integral of 1 over x is going to be natural log of x. So this becomes natural log of x, and the integral of e to the x is itself e to the x. Okay, so this would be minus 6. The 6 is a coefficient it comes along with for the ride, and it'll just be exactly itself. So this would be the integral of I. Okay, last one, we have 5 over x plus 11 over x cubed. So let's go ahead and rewrite this so that we can take the integral. Much like with an example above, we have a 1 over x situation, like in letter I, and we have a power in the bottom, and we would need to bring that up like we did in example E. So let's go ahead and rewrite this so that we can integrate, because we can't integrate right now. So I want to rewrite this, so this would become 5. I'm going to take out the 5 so it's easier to see the natural log integration. So 5 times 1 over x. And I'm going to bring up that 11. Sorry, I'm going to bring up that x cubed. So it'll be x to the negative 3. And this is all with, don't forget our differential dx. Okay, so now I want to take the integral of this function. So much like in example I, we have a 1 over x. And so the 5 is a coefficient. It comes along for the ride. So the integral of this first part would be 5 natural log absolute value of x. And so now we need to integrate 11x to the negative 3. Same thing, we're going to add 1 and divide by negative 3 plus 1. So we get 11 times x to the negative 3 plus 1 over negative 3 plus 1 plus c. So if we simplify this, we get 5 natural log of x minus 11 x to the negative 2 all over negative 2 plus c. So I want to rewrite this one more time. 5 natural log of x. And I'm going to simplify out this negative. 2 negatives make a positive and make it a fraction. So it will be plus, and I'm going to bring down this x to the negative 2 to make it a positive exponent. So becomes 11 over 2x squared plus c. And that's my solution. So that's it for example 1. All these practice problems here. Thanks for watching. I will see you next time.